Good afternoon, everyone, and happy spring. I'm Catherine Brookman, Associate Director, Knowledge Transfer and Exchange, and on behalf of Dr. Jack Callahan, Director of the Center of Research Expertise for the Prevention of Musculoskeletal Disorders, or CRE-MSD as we are more commonly known, we'd like to thank you for joining us today for this free webinar on anti-fatigue mats and their relationship to MSD prevention. We are grateful to the Ministry of Labor, Immigration, Training and Skills Development for our funding, which supports the delivery of these webinars, and to our presenters who provide their expertise. This webinar will be recorded, with the recording being made available to you on our website, along with the presenter slides shortly after today's webinar. The format of today's webinar is as follows. The presentation will be given, after which time we will have 10 to 15 minutes for a question and answer period with our presenter. During the question and answer period, we ask that you type your questions into the chat box. The chat box can be pulled up on your screen by selecting the chat icon in the control panel that appears near the bottom of your screen. I will relay these questions to the presenter or a similar question should we have duplicate themes. You will be muted, just to remind you, for the entire presentation to ensure there is no background noise for disruption. Should you have a pressing question or issue, such as a technology glitch that cannot wait until the end of the presentation, please type this into the chat box and we will do our best to address it right away. At the end of the webinar, you will be sent a link to an evaluation. Please fill out this evaluation as it will assist us in the future delivery of our webinars. Thank you so much for joining us today, and remember to watch the CRE-MSD website and the MSD prevention website for other resources and events. Our next webinar will be taking place on April the 15th, conducting home office virtual assessments. How is it done, and what you need to know to set up your home office workstation. Now it is my pleasure to say a few things about today's presenter, Dr. Andrew Laing. Andrew is an associate professor in the Department of Kinesiology and Health Sciences at the University of Waterloo. His general field of interest is musculoskeletal biomechanics related to human health and injury prevention, and the role that advancing age has on these relationships. Andrew's current research program focuses on two injury categories: workplace musculoskeletal disorders and fall-related tissue trauma, including hip fractures, spinal cord injuries, and traumatic brain injuries. His workplace research interests involve the development and implementation of participatory ergonomics processes in industry, assessment of potential age-related differences in knowledge capital, and physical work capacity associated with manual materials handling, and the effects of floor designs, properties on risk factors for work-related musculoskeletal disorders in residential care facilities. His work will support interventions to promote healthy aging and work ability across the lifespan. It's now my pleasure to turn this over to Andrew.
Well, thank you for the introduction, Catherine, and thank you for the invitation to present as part of this seminar series. So the focus today is, as indicated in the title, will be on anti-fatigue mats, or I may refer to them as AFMs throughout the presentation. So just a little bit of background about myself. This is my great-grandfather and my father sitting on his lap. You might notice that there's a cane on the ground, and that's because my great-grandfather was a farmer. He fell off the hay wagon, landed on a rock, and fractured his hip. And from that day on, his ability to work in his chosen occupation as a farmer was impaired. And so the profession of ergonomics and injury prevention is really important to me. And my father, who was sitting on his lap, ended up being a health and safety consultant for his profession. And so I use these sort of on a daily basis to try and motivate me towards making a difference in the workplace for people. A little bit of background, I did a kinesiology degree. And throughout my undergraduate degree, I worked within the steel sector at Stelco, worked within uh, the manufacturing sector, within bags of all things, garbage bags, as well as food handling materials, and also within the automotive sector and the transportation sector, looking at how fatigue influences driver safety. Um, and masters, I moved on to the manufacturing sector within the automotive industry. And then took a deviation, but focused on my hip fracture interests for my PhD and then postdoc looking at spinal cord injuries. But all of this brought together brings me to the overall framework for my research program. And at the end of the day, I'm trying to do research to provide evidence to support interventions to reduce the risk of injuries. And those injuries can influence mobility or workplace performance or functional independence in older age as well. And the categories that I generally focus on are either work-related injuries or fall-related injuries. Okay, with that background, I put together a smattering of different workplace settings that the audience might be familiar with or might work within. And I want you to think, spend maybe 5 seconds here, 10 seconds, and think, what is a common feature of all of these different workplace settings? And it's harder to gauge when I can't see you folks, but I'm sure you're intently looking at all these workplaces. Okay, so the answer that I'm going to provide today is they all have floors. And that's not what people were expecting, I suppose. But it's one common feature which raises the, the specter of, is the flooring within a workplace setting related to work-related injury risk? And every time you're standing on a floor, there's forces that floor is providing up into the body. And this has provided me with a career's worth of a research exploration. Okay, and so if we're to focus on standing balance, I'm just going to give a quick primer here. If we're looking at prolonged standing as what we're trying to intervene upon with anti-fatigue mats, whenever you're standing, and I'm going to ask everyone to stand up now. It's good for exercise and movement during your lunch break as well. And so for those that are standing, I want you to try and see whether or not you notice that everyone sways back and forth during standing. It's just natural. And that's the center of mass is moving back and forth. Now, if we weren't to do anything about this, we would fall over. And so the center of mass, or sorry, center of pressure, which is underneath our feet, which are those forces that come up from the ground into our body, we use that to move back and forth to try and control the center of mass. So if we were to have a relationship between these two things, the center of pressure and the center of mass, the center of pressure is like a sheepdog, and it's running back and forth to try and corral the center of mass and keep it in the desired location. And if we were to look at the center of mass, it's this line here over time, and our center of pressure is always moving outside of it to try and push that center of mass back towards the middle or the equilibrium point so we don't lose our balance. So we're talking about anti-fatigue mats as well, and essentially what they boil down to is a compliant material is what most anti-fatigue mats are in principle. Now, from a pure balance control perspective, if we put a compliant material between the floor and our feet, that causes problems. It creates instabilities, which make our center of mass move back and forth to a greater degree. And it also then impairs the ability of our center of pressure to move effectively. So it's delayed, which causes problems from from a balance control perspective. So you might consider from a pure balance control that putting a compliant material is actually not a good idea. So let's switch over to think about um, pain and pain development or MSD during prolonged standing. Some of the theories suggest that pain or injuries can result predominantly from the person being in a static position for extended periods of time. And in those static positions, the same tissues are loaded. You get pooling of fluid like blood within the lower limb, buildup of metabolic wastes. And all of these can contribute to the development of pain and subsequently can, in theory, lead to musculoskeletal injuries. So if we were to tie these two together in terms of putting a compliant material or an anti-fatigue mat, the proposed mechanisms by which an anti-fatigue mat might help would be to intentionally create instability. And that instability results in increased movement of the body, which then shares tissue loading between tissues. And your muscles have to actually engage to try and balance you. And that muscle contraction ends up as a muscle pump. And as a result, you have decreased static positioning during prolonged standing. The same tissues are not loaded, so you have a decrease there. You have a decrease in pooling of fluid and a decrease in metabolic waste buildup. And so these are the proposed mechanisms by which there's a decreased risk for developing pain and musculoskeletal injuries. So that's the theory, anyways. And I'm going to start with a, uh, a really good review paper as a quick follow-up here. But at the end of the day, this is the theory. The research really remains to be done to see whether or not anti-fatigue mats do a good job at reducing pain and injury. What are the mechanisms underlying that, and what is the optimal design? So review paper 2018, Speed and colleagues. I'll refer the group to this really good work. But at the end of the day here, they found moderate evidence that compliant floors can decrease discomfort or fatigue within the workplace. Um, Now, you can actually create instability instead by using insoles rather than anti-fatigue mats. And they found limited evidence in favor of insoles versus anti-fatigue mats. But a big portion of their conclusions were that better research needed to be done to inform industry decision-making and recommendations. And so that's what we're here for today, is to talk about some of the recent research. Okay, this particular study is published in Applied Ergonomics, and it focuses on transient pain developers. And so some of the existing research within the anti-fatigue mat domain really focused on looking at everybody, all workers. But during prolonged standing, there's a portion of the workforce that naturally experiences elevated rates of pain just due to the nature of standing in this case for a 2-hour period. And so these pain developers, no one is really focused on them when assessing the effectiveness of anti-fatigue mats. They just lump everyone together. And so the focus of this paper was to really differentiate between pain developers and non-pain developers. So we collected a whole host of measures over a 60-minute prolonged standing period. Our primary measure was pain or discomfort, but we also collected a bunch of biomechanical mechanistic measures as well. And the anti-fatigue mat in this case was an 11.5 millimeter rubber mat. We looked at posture, body movement, and our COP, but our primary focus was on pain or discomfort. So as expected, over the course of the 60-minute prolonged standing period, pain levels increased for everybody in both the rigid flooring and the anti-fatigue mat condition. And so there's two groups here. Our PD is our pain developer group, and our NPD is just our no pain or control group. So at the end of the day, pain levels increase for everybody over the course of the prolonged standing condition. But the important thing in this figure is that our pain developers are in black. And on a rigid floor condition, our pain was much higher than in our anti-fatigue mat condition. So those pain developers derive benefits from the anti-fatigue mat, whereas there was no significant difference at all for our non-pain developers. So the mats worked, but not for everybody. In terms of the overall mechanisms here, the COP excursion, which is that sheepdog sort of parameter, uh, the mats increased it for everybody. And our body weight shifts, which are movement patterns, increased for everybody as well. So despite the fact that the mats were creating these instabilities and movements for everybody, they only related in decreases in pain levels for those original pain developer group. And our lumbar postures weren't affected, which I haven't shown in this figure. Okay, so take home message here is that anti-fatigue mats, or at least the ones studied in this study, can reduce low back pain. However, the benefits were not similar for everybody, and they existed only for those that were predisposed to experiencing increased pain during standing. And there's some information or data there that supports the underlying mechanisms for these benefits. But at the end of the day, as a sort of a workplace recommendation or actionable item here, it could be that AFMs are good for particular individuals within the workplace or pain developers. Okay. Um, as we were doing this work, there's questions related to how much deformation was happening within the anti-fatigue mats. And if there is too much deformation when people are standing on them, could this cause trip hazards? And so this follow-up study was looking at footfall deflections, or how much deformation into the mats there were. So we had 5 different mat conditions with different stiffness values or geometers within the same anti-fatigue mat. We simulated 3 different types of workers. We had mass that went from a 10th percentile female all the way up to a 90th percentile male. And we simulated single leg stance on these mats for a 15-second period. And we used a materials testing system, which essentially just squishes the mats. And we measured the vertical deformation within the mats themselves. So we have a 15-second loading period here. And in general, at the end of the day, we found that our deformation within the mat increases over time. So for prolonged standing, the mats continued to creep and there was increased deformation. And the deformation was more for heavier workers. Now, what was really interesting is that we could end up predicting what that deformation would be as a workplace practitioner by looking at 3 factors. So the vertical deformation here, or in green here, could be predicted by body mass of the worker, the time over which they were standing on the mat, and the shore hardness or the compliance of the anti-fatigue mat itself. So this gave us some ability to predict if we have some target deformation maximum that we're looking at within a workplace. Okay, so take-home messages here. That fall deflection could be predicted from sort of work organization factors, time for prolonged standing, as well as worker factors, and mat factors. Now, the largest deflection that we observed was 3.5 millimeters in this study. And so for clinical relevance related to the fall risk, this is lower than toe clearance during gait, uh, but it's unclear, or we didn't test specifically how that might influence workplace fall risk. But after this study, we got interested in, we're always looking at sort of the worst case scenario whenever we're trying to intervene within the workplace, or what mistakes might get introduced. And we were interested in what would happen if there were heavy equipment that got placed on these anti-fatigue mats. And so we came up with a worst case scenario. What happened if a forklift got parked on one of these anti-fatigue mats? And so we were particularly interested in the surface area of the tires of a forklift. And so we simulated that within this particular study, and that we loaded the mat up to 1,700 pounds. And in this case, we observed about 16 millimeters of deformation. And this certainly reduced the kind of protective properties of the anti-fatigue mat, as well as would certainly introduce a trip hazard within the workplace. And 5 hours after loading, it still hadn't recovered, so there was permanent damage. So this study demonstrated that there is some residual damage that's possible for heavier loads placed on anti-fatigue mats. And this residual damage or the deformation is dependent on mat properties, including geometry or stiffness or design. And some of the underlying columns in this case were just permanently deformed. Okay. So if we go back to my original framework here, we've got work-related injuries, and we also have fall-related injuries. And this has led to an intersection is, can anti-fatigue mats reduce the risk of both of work-related or fall-related types of injuries within our classic MSDs anyways within the workplace, as well as fall-related work injuries. So this study is focused on the anti-slip properties of anti-fatigue mats, because some commercially available products do try and build in anti-slip properties into classic anti-fatigue mat designs. And so we were looking at, in this case, does the design of the anti-fatigue mat influence friction or slip resistance? And importantly, could we develop a test method that would allow workplace practitioners to test kind of frictional properties across anti-fatigue mats in the field? So this is really basic, but we simulated a 30-kilogram load within this steel-toed boot and used a hand pull technique to try and slide the boot across the anti-fatigue mat. And we have a load cell here which allows us to calculate friction variables. In addition, we used a more controlled, just a linear actuator or a motor pull to slide the boot across the anti-fatigue mat. And ultimately, we're comparing across floor conditions or mat conditions, but also across those test methods. So take-home message here is that friction did vary across different mat designs. This was more of a smooth baseline condition. These ones had ridges as well as some gaps for fluid to drain out. And then the last one, this was a grit. It actually had grit embedded on top of it as well. And as expected, our grit floors did demonstrate higher frictional values than our baseline. A take-home message here is that the hand pulls did a good job, although there were slight differences in the actual friction values. The rankings across the floors were similar for both the motor pulls and the hand pulls, which means this could be useful within a field setting. And the last thing I'll note here is that classic measures of friction would be static coefficient of friction or mean dynamic. But we found that peak values of friction as well as variability, and so how much change in friction there was as the boot slid across different ridges, were really good at identifying potential slip resistance properties. So I'll take a step back here and indicate there's some potential limitations with anti-fatigue mats, and to name a few here, um, could they actually cause trip hazards, which we've talked about briefly, but the areas that are protected are only where the mats are placed, and so there's limited spatial areas that could help workers. Um, and it's unknown whether or not they could really be protective across other types of injuries, such as falls within the workplace. And so this has been a big element within my research program, is looking at broader safety flooring within workplace settings. And safety floors, then, they're generally purpose designed to reduce injuries. Now, this particular commercial product initially started as an anti-fatigue mat that was originally designed for that purpose. And then they started to think, you know what, this might have added benefits during fall-related injuries from impact attenuation. And so now you can buy it in both forms. And this is essentially a subfloor um, in which you can put vinyl or carpet on top of that subflooring system. So I'll boil down a lot of research into two slides here, is that safety flooring systems can substantially reduce impact forces, and this includes hip impacts or falls on the hips, as well as falls that result in head impacts. Um, and the good news is that the impact attenuation tends to be higher for those at higher risk of fall-related injuries or frailer individuals. Okay, what about effects on balance? And so the good news here is that there are some safety flooring designs which can be have minimal effects on balance, because we don't want to cause people to trip or to fall. And this has been shown across a whole host of different types of mobility activities or activities. And so we've actually installed safety flooring technology within 5 suites within a local retirement home facility. And we wanted to get perspectives of workers on how these floors might influence a whole host of things, including work practices. And the good news in this case was that there were positive responses from our workers. Um, Everything which is positive here is a beneficial rating, and so our workers thought there was positive effects for residents from the perspective of workplace practices and also novelty and attractiveness, but we're most interested in this category here. Okay, so the take-home messages here is that anti-fatigue mats and safety flooring technologies are generally based on the same principles, which is compliance of the flooring surface and energy absorption. So in some workplace settings, it's possible that anti-fatigue mats are the proper or correct course of action. And in some cases, safety floors, broader safety floors might be appropriate. So they're workplace specific. But important considerations here come down to finances. And so I'm happy to chat about cost benefit perspectives in the question and answer period. All right, so I'm going to finish up here today and with some current sort of stuff that I'm really excited about. And I want you to have a look at these pictures, because one of these is an anti, or at least marketed or sold as an anti-fatigue mat, and one of them is marketed and sold as a fall mat or injury prevention mat for falls. So have a look here and see if you've got any thoughts as to which one is which. Okay, so let's let the cat out of the bag here. So the fall mat is the gray one, and the anti-fatigue mat is the one on the right. But if you were to look at them, you would have really no idea which one is which. They're based on the same premise, which is compliance to help with creating instability during prolonged standing or attenuating impact and absorbing energy during falls. So if the design principles are so similar, um, could we create a single product which is effective for both purposes? And so I'm working with a local industry partner um, to actually go about trying to answer this question, and that's Custom Foam Systems in Kitchener. Um, and so the goal here is to look at um, 5 different geometer conditions. So the mats that they produce are polyurethane foam, uh, and they're creating them in 5 different geometer or stiffness conditions. So my lab is just full of anti-fatigue mats at this point. And we're testing those 5 mat conditions within 3 sort of paradigms. So for prolonged standing perspectives, from an impact attenuation perspective, and then a balance control perspective, just to make sure that fall risk isn't increased across these different geometer conditions. So on the prolonged standing front, these are kind of focused on healthcare applications. So we have a 75-minute prolonged standing task, and pill sorting is what the participants are focused on. And these are just done with colored beads to simulate kind of pill sorting task in healthcare. Our primary outcome measure here is pain or discomfort in different body regions. And we're also interested in sort of underlying mechanisms. So we're looking at posture, muscle activation, our center of pressure excursion underneath the feet, as well as blood oxygenation with NIRS values. If we move on to the second sort of domain, we're looking at impact attenuation. And so on the left-hand side here, we're simulating hip impacts. So I'll pause this just. So on the left, we have a simulated hip bone and ballistics gel to simulate the soft tissues around the hip. And we simulate the impact velocities when people fall sideways onto their hip in workplace settings or in residential care facilities. And on the right-hand side here, we've got a hybrid 3-head form, which we're using to simulate impacts to the back of the head, as well as to the front of the head, which are common impact sites during falls. And in both cases, we're measuring what impact forces are and how those forces are decreased by anti-fatigue or mats, in this case, across different geometer conditions. All right, so what are the results showing us so far? And unfortunately, this is hot off the press. We're conducting these studies right now, so I'd be happy to come back and share details in a webinar in the future, or I'd be happy if people were to reach out to me to share what some of the outcomes are for this particular study. But again, I want to thank Custom Foam Systems as our local industry partner for their involvement in this study. Okay, so I wanted to leave intentionally lots of time for questions. So I'm going to wrap it up here. Um, but beforehand, I'll just create some take-home messages. Um, so at the end of the day, anti-fatigue mats do demonstrate an ability to reduce low back pain for some people. They might not necessarily have much effect for those who aren't predisposed to back pain during prolonged standing, but for that subset of the population, which is around 30 to 50% of individuals, anti-fatigue mats in our work have been shown to reduce uh, pain and discomfort. Uh, which anti-fatigue mats should you purchase for your workplace if you're interested. There's no one size fits all answer to that. There's a whole host of workplace setting factors that you need to consider, including durability, contaminants, and I'm happy to talk about some of those factors in the Q&A session. Uh, what are the perfect or optimal parameters or softness geometry settings for anti-fatigue mats? We're still trying to answer that question because at the end of the day, these compliant materials, they're impairing our balance a little bit. So we have to come up with an optimal balance between being too soft or not soft enough. And finally, the point to make here is that keep your eye out for these hybrid products that are really aiming to do more than act as anti-fatigue mats. And these might come in the form of slip resistance or fall prevention mats or impact attenuation in the event that falls occur within the workplace. So at this point, it's the lab members that do most of the work. So I want to acknowledge all the staff and grad and undergrad students that help perform this work, as well as my colleagues as well. And then funding sources. So thank you to CRE-MSD that helped fund to support some of the work presented in here, as well as industrial partners and other funding sources. So at this point in time, I'd be happy to chat, have discussions as they're relevant to your workplaces.
Thank you so much, Andrew. You've given us a lot to think about across all different kinds of industries, and we've got a lot of questions here. So I'm going to jump right in with as many as we can get through to one
Okay.
o'clock.
I'm going to
In the,
try and plug my second monitor in so I can monitor some of these questions as well.
okay.
So.
And while you're doing that, I'll throw out the first one that came early on. If anti-fatigue mats don't work for all, how do we know which population would benefit from it? So that was from your early research.
Yeah, that's a really good question. And identifying who might be at most benefit from mats, uh, at least from our work, comes down to trying to figure out who these pain developers are, and that just natively, when exposed to prolonged standing, kind of develop pain. And so within, I'm not sure which workplace setting this questionnaire is within, but you could actually have some screening and ask people about what their pain levels are over the course of a shift and use this to help guide uh, who, and this is, it's a difficult decision in terms of who might be allocated an anti-fatigue mat and who doesn't qualify potentially. But those who have higher complaints of pain or discomfort are likely more to benefit from anti-fatigue mats from those that generally don't have as much problem with prolonged standing.
And Hollis from healthcare has asked a similar question, just how do you identify pain developers in the workplace?
Good. And so there's something that our visual analog scale, there's a little software program that's available now, and Jack Callahan, I think, can provide more details on that. But it is a rating scale for pain or discomfort. And so practitioners may be able to, and this is an app that can go on your mobile phone or your iPad, for example. And so just asking participants at the start versus at the end of the shift what their pain ratings are for the low back could be a screening process.
Interesting. I think about dentists, and my father-in-law is a retired dentist and has an incredible amount of hip pain. And we don't know whether that's a result of the profession or if it's genetically related uh, to arthritis. Uh, so lots of factors and lots of professions would need to look at things. Could you explain, Andrew, what you mean by maximum friction being predictive of anti-slip properties? and how does it relate to static and dynamic?
Good. Okay. So in terms of slip resistance, generally friction is kind of is the metric we use to measure the slip resistance of a flooring material or mat. And so something that has high friction uh, can is going to be less. It'll be resistant to slips within the workplace. Now, too high of a friction can also be considered as a potential fall hazard as well. Um, but our static coefficient of friction, that measures what the friction is just to initiate movement of the foot on the floor. So how much do you have to pull in order to get it to start moving? And our dynamic friction is how much load you'd have to use to move the foot after it's already started to move, to keep it moving. And so static is sort of a classic, and it's usually higher traditionally um, than our dynamic. Once you get it to start moving, it's a little bit easier to keep it moving. And our work is showing here that the mean values might be a little less predictive of slip resistance compared to either the peak values or how variable that dynamic friction value is as the boot or the foot slides across the flooring material.
Thank you. And another question related to ongoing movement. Has there been any feedback from the Schlegel case study in moving wheeled objects across those surfaces?
That's a wonderful question, and we spend a lot of time on this as well, thinking about how work practices are affected. Um, and within a healthcare setting or a residential care facility, we have wheeled devices such as walkers for residents. Wheelchairs are another factor, and but also laundry carts and food services carts themselves. So we have not, as of yet, tested the effect of these floors on rolling loads um, for sort of occupational carts and whatnot. But the manufacturer of this particular product that was installed there has done a lot of tests on that factor and have shown that it does increase, but this is the one thing left for us to do is to compare those pushing and pulling loads to occupational sort of criteria for pushing and pulling forces.
Thank you, Andrew. With the new flooring, do resupply staff have to provide greater push force over the new flooring? And if so, how is that mitigated?
Yep, and so this builds right on the previous answer
Yeah.
there, is to uh, anecdotally, I suspect it will increase those pushing and pulling forces. And so we just need to ensure that they're below occupational limits. Um, and it, this brings a really interesting question for this workplace setting within residential care is that traditionally the residents that get a lot of the focus in terms of injury prevention. And workers generally within those settings are compassionate. They're there to try and help the residents themselves. But we want to make sure that any interventions that we implement are not doing so at the expense of worker risk as well. So ongoing studies to help characterize that.
Thank you for that. What is the durometer range for the mats?
Yeah, that's a great question. I think we were from, I can look back, but I think it was in the neighborhood of 80 to 95 for the shore age geometer in the footfall deformation study that we looked at. Now, the geometer for some of the polyurethane foam mats will be a lot lower than our rubber mats. And in some cases, they use an entirely different geometer scale. They're looking at CF geometer as opposed to shore CF geometer as opposed to shore A. Um, yeah.
Okay, I'm going to jump into the next question. When looking at previous research regarding objective measures for standing fatigue, not falls, the issue was that there was no common measurement method,
Mm.
muscle activity versus blood flow. Have you found this still to be true? And perhaps this is your reference to staying tuned. Your
Yeah,
cliffhanger.
yeah. Well, it's a great question. And so the systematic review I referred to earlier in the slides, that was one of the take-home messages that they had, is that it was hard to compare across studies. Um, Everyone is using different metrics to try and kind of test the effectiveness. And so our general approach now is to try and do a comprehensive job. So we're collecting everything but the kitchen sink here, um, in terms of looking at muscle activation, blood oxygenation, kinematics or body movement, in addition to pain levels as well. Um, the more that we collect, the better we'll be able to compare it to other studies in the literature. But which is why we're also looking at things like friction testing as well now, as we're interested in characterizing as much as we can when we're doing these studies.
So building on that, Andrew, going back to pain developers versus non-pain developers, what criteria did you have or what differentiated these two different groups
That's
other than pain? Like what was the criteria for I have pain?
great. See if I can, wouldn't you know what my, oh, there we go. I'll try and go back to that
Okay.
slide. Perfect. And so our pain developers versus non-pain developers were based explicitly on sort of the change in pain during the rigid floor condition. So this was our baseline before we'd introduce the anti-fatigue mat at all. And so if we were to look at the rigid is the blue in both cases here. So the dotted blue is going to be our non-pain developers, and the solid blue is our pain developers. And I think the criteria um, for a pain developer is a change in maybe 10 millimeters on this visual analog scale for discomfort. And Jack Callahan can provide more insights, and there might be some on the call here that might have remember the specifics themselves. But that pain developer versus non-pain developer was on the basis of reports during this prolonged staining in the rigid condition itself.
And and on a certain type of surface.
On a rigid surface,
Yeah.
yes.
Okay.
Yeah. In our case, it was on a force plate, but that would be similar to standing on concrete, for example.
Okay. Has it been looked at whether if you are wearing proper footwear with good support and structure as to whether the anti-fatigue mat has significant additional impact?
Oh, this is a wonderful question.
And you did talk about insoles not having an impact.
Yeah. Well, so insoles, I just to be clear, there's just less conclusive evidence about the effectiveness of insoles, not that uh, they don't work. Um, and so we wrestle with this as well in our research, is trying to determine what footwear condition should we kind of make sure people are wearing uh, when they're coming in for the mat testing. Um, and unfortunately, it's a great question, and there is no good answer on this, whether or not a sufficiently supportive and cushioned shoe is enough, and that whether mats will provide any additional benefits. I wish I knew the answer to that.
You and a lot of shoe producers, manufacturers. Has your research looked at an increase in knee injuries when using anti-fatigue mats?
So the quick answer to that is no.
Okay,
We have not. Uh, but it's an interesting question because the overall premise of how anti-fatigue mats work is is by creating instabilities, and these instabilities can create some sort of increased muscle activation or movement. Um, and so you could make an argument that there is a sort of a mechanism by which you might have increased risk of pain in other
areas.
locations as well. Yeah, but I we have not looked at it. No.
Okay. Back to the long-term care study. Did the safety flooring installed suffer any permanent deformation due to resident beds? Not sure if you were able to have a look at that.
No, that's a great question, and we did actually consider that. Uh, and so it's similar if you have a heavy kind of chest of drawers within a bedroom or a couch in a room where there's carpet. If you move the couch to occasionally vacuum underneath it, you're often going to see those kind of dents in the carpet, which is from the point loads of that heavy furniture. And so for the purpose of the this safety flooring, yeah, you see similar types of sort of deformation. And so the workaround for that is just like you would have with classic carpets. At least I know on my couch growing up, we had these little like almost little saucers, for lack of a better word, but they essentially they increase the surface area. They went underneath the legs of the couch or the drawers and increase the surface area over which that point load is spread. Now, interestingly, this particular product, if they knew where the beds were going to be installed at installation point, you can actually purchase these plates that get embedded in the subflooring around the compliant columns that essentially create rigid points that won't deform um, uh, underneath those point loads. So there's two ways to do it, during installation or as well post hoc with kind of force spreading plates.
Interesting, very great application for architectural designers.
Mhm.
Um, I think you've answered this. What percentage of people are typically pain developers from prolonged standing?
Yeah, this is a great one. I'm
Yeah.
not sure if Jack is on the line here, but I think we're in the neighborhood of 30 to 50% would probably be a reasonable answer to that. But if others in the chat here want to chime in, I'm happy to have some more details there. But it's enough that it is a substantial portion of the population.
Okay. And just back to the questions related to insoles, was there any supporting evidence showing benefits for the overshoe products, concerns of modifying footwear and potential increasing tripping risks?
Really interesting. And I feel bad, but I keep on having to answer saying I don't
Lots of
have an answer.
potential research here.
Yeah, but you can certainly make an argument that kind of changing your typical shoe geometry or mass could change sort of gait patterns and could have the potential to increase tripping or fall risk. But I don't have any data or haven't seen any to be able to comment though.
Okay. Are you able to comment on low leg muscle activation and fatigue when using anti-fatigue mats?
Yeah, I mean, this is a great question. Um, and so if we think about the premise of the mats themselves and here, maybe I'll shoot down a couple of slides. Perfect. Okay. So the forces or the loads during prolonged standing are not overly high. And so the challenges come from these static positions and relatively low level EMG. And so it's fatigue due to these static positions, not sort of high activation levels. Um, Now, interestingly, when you, in theory anyways, you stand on these mats, it's going to increase movement and increase muscle activation. But the theory anyways is that the static low level gets attenuated. So you might have greater muscle activation for a period and then it goes down to a lower level and then up a little bit higher again. And so it's this variation in activation, which might then influence fatigue values. They're marketed as anti-fatigue mats, and so the premise is that they're reducing fatigue. There's not a lot of really good research out there as to how that the muscle activation on anti-fatigue mats scales or correlates with uh, metrics of pain or discomfort, though.
Andrew, I'm going to end on a question, and there are additional questions that we will not be able to get to um, because this is something maybe we can control ourselves. Good footwear travels with the individual. Mats are stationary. Based on your research thus far, is it a better answer, better footwear?
Uh, yeah, and you can make the same argument for flooring as well. Floor like overall flooring, it's is protective wherever you are within the workplace. Um, and the answer is, and I'm feeling bad here, is that there isn't enough good research to answer that question. But I will suggest that um, anything that gets between a person's foot and the floor has the potential to give these sort of benefits that we're talking about. And so it is absolutely something that I would recommend is good quality shoes and make sure they're not getting uh, sort of worn down and that people will kind of replace their shoes when necessary. Um, and at the very least, the quality of the shoes and the properties of the shoes should influence how well an anti-fatigue mat might work. So if you're looking at investments from a workplace perspective, you could certainly make an argument in terms of investing in worker footwear, depending on whatever the fiscal programs that you have set up within your workplace. But
Thank you, Andrew. Just an excellent webinar. So much interest, so relevant to everywhere across so many industries and in our life in general. So thank you so much. I
great,
expect we will be inviting you back in the very near future, especially since the Ministry of Immigration Training and Skills Development is looking at a falls risk and MSD campaign. So thank you to everyone who's joined us, and we look forward to hearing more from you in the future, Andrew.
great. And I'll just a quick shout out. So thank you for those that attended today. And I would be happy to talk with any of you if you have questions. And also if you've got some interest in partnered research as well, happy to share ideas with folks. So thank you.
Thank you.